All right, let's go over building unit circle. First, we understand that this is a unit circle, meaning that the radius is 1. So imagine this is 0, 0. We can find order pairs by anything that's along the horizontal or vertical, which is 1 unit away. So if I want to move 1 unit to the right, my order pair here is 1, 0. If I move 1 unit up, order pair 0, 1. 1 unit to the left, negative 1, 0. And 1 unit down, 0, negative 1. Okay. In terms of angle measures, we know the easiest angles to find are the ones along these quadrant angles. So we know this is 0 degrees. This is 90 degrees, 180, and 270. And then if we circle back to our starting point here, we can also call this 360 degrees. Okay. All right, now in terms of radians, we also talked from last section that 2 pi is the same thing as 360 degrees in terms of radians. So we can say for radian measures, I can say 0 and 2 pi. 90 degrees is pi over 2, or 1/2 pi. 180 degrees is pi. And then 270 degrees is equivalent to 3 pi over 2 radians. All right. Okay. Now, all of these order pairs follow this pattern in terms of we can find these trig ratios of these specific special angles. So your x value is going to correspond with cosine of theta, and your y value is going to correspond with sine of theta. So we can think of cosine as our quote-unquote x value. We can think of the sine as our quote-unquote y value. Okay. Now, these special angles here, these are all variations of 30, 60, 90 triangle or 45, 45, 90 triangle. So this is 30 degrees, 45 degrees, and 60 degrees. Okay. So we learned from the special right triangles that with, for instance, with this hypotenuse radius being 1, this is really just a 30-degree angle, which means that this is 60 and this is our right triangle. And this is our short leg, this is our long leg. And we know that the short leg is half the value of hypotenuse, and the long leg is root 3 over 2. So therefore, if I want to reach this ordered pair here, I have to move to the left root 3 over 2 and I have to go up 1/2. So that's why this ordered pair is root 3 over 2. And 1/2. Okay. With the 45 degrees here, this is going to be a 45, 45, 90 triangle. And if my hypotenuse is 1, my legs are going to be root 2 over 2 and root 2 over 2. And likewise, the 60-degree angle here, this is also a 30, 60, 90 triangle, but everything will be flip-flopped. My adjacent is now going to be 1/2, and my height is going to be root 3 over 2. So that's why this is 1/2 root 3 over 2. All right, now these are the most important ratios here, because if we can fill out the first quadrant, then everything else along the unit circle, second, third, and fourth quadrant, are just variations of what we see here. Okay, so here's a way to memorize these values here. And one way to do this is understanding that first is that all the denominators have the same value of 2. I'm just going to put these order pairs again on the side just to kind of show the pattern here. So, right, all the denominators have a y value, are the same with 2 in the denominator. So if we start at the upper left corner here, upper left corner of these order pairs, you're just going to count. So you're going to count 1, 2, 3, and then back up the chain here. So 1, 2, 3. All right, next up, you're going to put square roots over all the numerators. So square root of 1, square root of 3, square root of 2, square root, just the numerators. Okay, square root of 3. Now square root of 1 is the same thing as 1. So we can drop the square root and leave that alone. Okay, so the reason why this is helpful is because now we can find cosine and sine of all these angle measures. Okay, so if I say cosine of 60 degrees, that means we're talking about the x value. So cosine of 60 degrees will be 1/2. Sine of 45 degrees, we know that's the y value with these order pairs. So sine of 45 degrees is √2/2. And for instance, here, if I ask sine of 30 degrees, that's the y value. That'll be sine of 30 will be 1/2. Now, the radian measure that corresponds in the first quadrant, think of this as fractions that gets larger and larger. So this is 1/6 pi, or pi over 6. This is pi over 4. And this degree is pi over 3. So think of this as 1/6, 1/4, and 1/3. Okay. Okay, so if we want to build our way around the unit circle, let's start off with our degree measure. So our degree measure, we're simply just going to be adding either 30 or 15 all the way around the circle. So the big gap is going to be 30 degrees, and the little gap is going to be 45 degrees. So the big gap here is 30 degrees, little gap here, 15 degrees. Okay, so if we go through and add either 30 or 15, we can reach the next angle measure. So if I start at 0, plus 30 is 30, plus 15 is 45, plus 15 is 60. Okay, big gap. So that's 30 degrees. 60 plus 30 is 90. Another big gap. 90 plus 30 is 120. Little gap. These are all 15 degrees. So 120 plus 15 is 135. Another small gap. 135 plus 15 is 150. Okay, so now big gap. 150 plus 30 is 180. Another big gap. 180 plus 30 is 210. Okay, so we're back to small gaps here. 210 plus 15 is 225. Plus another 15 is 240 degrees. Big gap. 240 plus 30 is 270. We already have that, so we keep going. Another big gap. 270 plus 30, 300 degrees. Small gap. 15 degrees. Small gap. 15 degrees. 315 plus 15 is 330, and then big gap, 330 plus 30 is 360. Okay, so next up, let's build these radian measures, okay? We have the quadrant angles, we have first quadrant, and now we're going to figure out what the rest of this is. Something to bring up is this is where it's important to understand and see reference angles, okay? So we see that 30 degrees, okay? So this is 30 degrees, obviously. a reference angle of 30, okay? And what else has a reference angle of 30? Well, we know that reference angle is going to be measuring against the x-axis. So we can find the angle measure that's closest to the 180 degree mark. So that's the 150. So if I ask for the reference angle of 150 degrees, you would say 30 degrees because you find the closest x-axis, which is the 180, and you subtract 180 minus 15 is 130. So these two angles, they both have the same reference angles. So there's some similarities between these, between reference angles. Okay. Now, there are two more angles that also has a 30-degree reference angle, and those are the angles that are closest to the 180 and 360-degree line in the third and fourth quadrant. So I'm going to highlight those angles as well. So all these reference angles that are 30 degrees, they all will have a denominator of 6 for the radian measure. Okay, so I'm going to put a divided by 6 pi, and we'll deal with the numerators later, but we know that all these denominator radian measure will have a 6 in the denominator. Same thing here. Okay. Next up, we can talk about the middle angles here. So 45 degrees, and we ask ourselves, well, what are the other angle measures that share the same reference angle as this 45 degree? And we can say that 135 degrees will do that. That 180 minus 135 is 45 degrees. So all the middle angles will have a similar relationship there. So other 45-degree reference angles are 225 and 315. So I'm just highlighting these with the same colors so that we can kind of see their similarities. Now, all the middle angles here, radian-wise, will all have a denominator of 4. So I'm going to go ahead and do that. So divided by 4 pi, divided by 4 pi, divided by 4 pi. Okay. Next up, all the angles that are furthest away from the x-axis, 60-degree reference angle. That's also going to be 120 degrees as well, 120 and 180. This will give us a difference of 60. So 120 also has a reference angle of 60. And then 240 and 180, that's also 60 degrees. And 300 and 360, that's also 60 degrees. Okay. And all the reference angle of 60 degrees will all share a radian denominator of 3. Okay. So let me go through one way of doing this. I'll show another way on another page. But if we think of this as fractions incrementing across the circle, let's focus on the big angle first. Let's focus on the 60 degrees. Okay, so I'm going to just be, we know 60 degrees is equivalent for radian measure as pi over 3. So imagine this is 1/3. Okay, so you don't forget about the pi. Just think of that fraction as 1/3. And what we're going to do is we're going to find, we're going to build off that 1/3, and we're just going to keep adding 1/3 around the circle. And when we come across that measure that there's a blank space, we're going to fill in the numerator. Okay, so now we're going to do the work of trying to fill out the numerator of all these radian measures. Okay, so I'm going to start off with a larger angle here. So I'm going to add 1/3. So 0 plus 1/3 is 1/3. So that gets me to this line here. 1/3 plus 1/3 is 2/3. So that's going to get me to this line here. So I see a blank spot here. I'm going to put in a 2. So now I'm sitting at 2 pi over 3. 2 pi over, or I'm just going to keep adding 1/3 to my next increment. So 2/3 plus 1/3 is 3/3, and 3/3 is the same thing as 1. Now that is going to be a duplicate, so we're going to leave that alone. But we're going to keep track of the fact that we're now sitting at 3 over 3, 3/3. So 3/3 plus 1/3 is 4/3. That's going to take us all the way down here. So there's an empty spot for us to fill in. We'll go ahead and put 4 pi over 3. Okay, let's keep track of the numerator. We're sitting at 4/3. 4/3 plus 1/3 is 5/3. There's an empty spot there, so go ahead and put a 5 there. Next up, 5/3 plus 1/3 is 6/3, and 6/3 will take us back to 2 pi. 6 over 3 reduces to be 2, so we're back at our starting point. Okay. All right, so next, let's start with the blue. Let's go with the blue next. We're going to add, think of this as 1/4, okay? So 0 plus 1/4 is 1/4, okay? And again, if we come across any duplicates, we're going to just ignore it and just keep track and keep adding 1 to the numerator, okay? So 0 plus 1/4 is 1/4. That gets us here. 1/4 plus 1/4 is 2 over 4. Now 2 over 4 is same thing as 1/2, so we'll leave that alone. That's already been filled in. So 2/4 plus 1/4 is 3/4, so 3/4. Go ahead and fill that in. Okay, we have a spot that we can fill in. 3/4 plus 1/4 is 4/4. Now 4/4 is the same thing as 1, so we'll leave that alone. That's just pi. 4/4 plus 1/4 is 5/4. Takes us to this line here. 5/4 plus 1/4 is 6/4. Now 6/4 is the same thing as 3 over 2, so we can leave that alone, but keep track in our head that our numerator is now at 6. 6/4 plus 1/4 is 7/4. Keep going. 7/4 plus 1/4 is 8/4. 8/4 is reduced to be 2, so that gets back to our starting point. Okay, so now finally we're going to do the 1/6. Okay, we're going to add 1/6. Now as we add 1/6, we're going to come across a lot more duplicates. So if we come across a duplicate, we just ignore it and keep going. Okay, so 0 plus 1/6 is 1/6. Plus 1/6 is 2/6. 2 over 6 reduces to be 1 over 3. We already have pi over 3 filled out. We'll leave that alone. 2/6 plus 1/6 is 3/6. That's a duplicate. 3/6 plus 1/6 is 4/6. That's a duplicate. 4 over 6 plus 1/6 is 5/6. So there we go. We have an empty spot to fill in. 5/6 plus 1/6 is 6 over 6. That's duplicate. 6 over 6 plus 1 over 6 is 7/6. There's a spot for us to fill in. All right, so 7 over 6. What plus 1/6 is 8 over 6. 8 over 6, same thing as 4/3. Leave that alone. 8/6 plus 1/6 is 9/6. 9/6 is the same thing as 3/2. 9/6 plus 1/6 is 10/6. 10 over 6 is the same thing as 5/3. We leave that alone. 10/6 plus 1/6 is 11/6. So there's our final spot to fill in. And then 11/6 plus 1/6 is 12/6. 12/6 is the same thing as 2. Okay, so now something else that's nice about the reference angle is that all the ordered pairs that are along the reference angle numerically will be the same. Now, the signs will be different, so let's talk about that. Okay, so first quadrant, all your ordered pairs will show positive x and positive y value. Okay. Anything in the second quadrant will be a negative x value and a positive y value. Anything in the third quadrant, you know it's a negative x value followed by a negative y value. And anything in the fourth quadrant is going to be a positive x and a negative y value. All right, we'll keep that in mind after we fill in these order pairs. So first, anything that has pi over 6 or 6 in the denominator or a 30-degree reference angle will all share this order pair. This is before our adjustments with our signs, but we'll just go ahead and put the numeric value down. Okay, so all the yellow, the ones I highlighted in yellow will all have the same order pairs initially. All right, anything in the blue, anything with a 45-degree reference angle will share this order pair, root 2 over 2 and root 2 over 2. Okay. And all the 60-degree reference angle, the ones I highlighted in purple, will all share the same order pair numerically. Okay, so now the last thing to do is to adjust the signs, right? We know that of all these order pairs, second quadrant, if there really is a second quadrant, we need the x value to be negative. So let's go ahead and make that adjustment. We want the x value to be negative, and the y value, we'll leave it alone to stay positive. So we'll go ahead and put a negative. Anything in the third quadrant, both the x and y values will be negative. So I'll take all my order pairs and adjust them to be negative. Anything in the fourth quadrant, positive x value and a negative y value. So make that adjustment. So here we have a completed unit circle. Okay, but I have one more method that I'd like to show you in terms of giving you another option to help you memorize some of these order pairs. So this is the left-hand memorization method, okay? So if you take your left hand and if you line it up, you can kind of imagine that your thumb is at 90 degrees and then your pinky finger is at the 0 degrees. And then and then your index, middle, and fourth finger will make up your 30 degrees, 60 degrees, 30 degrees, 45, and 60 degrees. So I'm going to go ahead and put that here just to label these angle measures here. And then also the radian measure that goes along. Okay, so 0, 1/6, 1/4, 1/3, 1/2. Okay. Now there's a formula that's going to allow us to find these order pairs that we created in the first quadrant. Okay. But first, let's just do the easiest things first, right? The easiest thing is that this is a unit circle. So we know along our x and y axis, we're just 1 unit away. So to the right, we know this order pair is 1, 0. We know this order pair is 0, 1. And then all these other order pairs will tell us information about cosine and sine. Okay. Now there's a formula here. I'll write that formula down and talk about how to use it. So the formula is square root of the number of fingers all divided by 2. Okay, so we know the order pairs for 90 and 0. We're going to find the order pairs now for the 60, the 45, and 30. Okay, so this is the finger method. You're going to let's do the index finger first. So index finger refers to the 60-degree line. You're going to take that index finger and you're going to fold it down. Okay, and now look at the remaining fingers that's showing. Okay, so to the left, it's going to be the number of fingers that is, we see one finger, so that's going to correspond to cosine. And then the 3 fingers here, that's going to correspond to the sine. Okay. So the formula is number of fingers, square root of number of fingers over 2. So we see one finger here, so we'll put 1 for cosine. And I'll put it over here so that it doesn't take up all that space. So square root of 1 over 2. Okay. 1 is for cosine, so that's where I put a 1 there. Let me make it more clear. Okay, and then the remaining fingers, after I folded down my index, is 3, and that 3 is going to correspond with sine. So it's going to be square root of 3 over 2. Okay, so next, let's look at the 45-degree line. Okay, so you take your middle finger, you're going to fold that down. So once you fold down your middle finger, there's 4 fingers remaining. To the left, it's going to be talking about the cosine. So we see 2 fingers to the left of the folded middle finger. So that's going to be root 2 over 2, and that's going to be talking about the cosine. Right. You have 2 fingers showing there. So square root of 2 over 2 is for cosine. And then 2 fingers to the right. This is talking about sine. So number of fingers there is root 2 over 2 also for sine. Okay, finally, 4th finger, the ring finger, we're going to fold that down. So if we fold that down, we see 3 fingers to the left. That's going to be your cosine. And then 1 finger to the right, and that's going to be your sine. So 3 root 3 and root 1. Now, we know that we can drop the square root because for 1, at least, because square root of 1 is just 1. So I can definitely feel free to rewrite this as 1/2. And then you can rewrite this as 1/2 as well. Okay. All right, one last thing I want to show. There's a nice pattern in terms of instead of adding the fractions all the way around, I want to show you a different way. So we did talk about, though, that reference angles with 60 degrees, they will all share a denominator of 6. So I'm going to go ahead and start there, and because this memorization trick is for the numerator. All the middle angles will have a denominator of 4. And all the angles for, at the 60-degree line furthest away from the x-axis will be divided by 3. Or okay, so here is a way of seeing another set of patterns with these numerators here. So anything in the second quadrant, okay, what you're going to see is that your numerator is going to be 1 less than the denominator. So what's 1 less than 3? It's going to be 2. 1 less than 4 is going to be 3. And 1 less than 6 is going to be 5. So there we have our radian measure filled in, or radian values, fractional values set up. Now, third quadrant, there's also a special pattern here. And it's the fact that your numerator is 1 more than the denominator. So if we look at this denominator here, 6, 1 more than 6 is 7. 4 is this denominator. 1 more than 4 is 5. This denominator is 3. 1 more than 3 is 4. Okay, in the fourth quadrant, the pattern, there's two ways of doing it, and you can kind of pick and choose which way you want to use it. One is there's a pattern numerically, but it's a little bit more involved. What you want to do is you can multiply the denominator by 2, and then subtract 1. So if I take my denominator, multiply by 2, 3 times 2 is 6, and 6 minus 1 is 5. Take 4, multiply by 2. 4 times 2 is 8. 8 minus 1 is 7. And then 6 times 2 is 12. 12 minus 1 is 11. Another memorization trick that I saw online is someone said there's a pattern here, the 5, 7, 11. You can say 5 days a week. I go to the convenience store, 7-Eleven. Okay, so 5, 7, 11. If you want to look at it from that perspective, you can, or you can do the algebraic way, or you can go through that adding fractional method that I went through. Okay, but hopefully that gave you some options to choose which way best works for you to eventually commit this to memory by building your unit circle in terms of the degrees around the circle, the radian measures around the circle, and also all the order pairs that correspond with the um, um, unit circle, with the cosine and sines ratios. Okay.